SN26 is graphing quadratics in vertex form, and 26.1 talks about how to find the line of symmetry of all three forms of quadratics. So before we get into how to find the line of symmetry, I just want to review what it is. So every parabola has a vertex. It's the point that it changes direction. So you'll see on the left sketch, the vertex is at the very bottom, and then on the right sketch, the vertex is at the very top. The line of symmetry is a vertical line that cuts through the vertex of any parabola. And it's called the line of symmetry because if you were to take the parabola and reflect it over that line, it would fall exactly on itself in the same exact position. So the line of symmetry cuts the parabola into two symmetric halves. Okay, moving down to the table, and I would recommend pausing the video here and copying down this table so you could follow along and have it to reflect back on. So the table is going to go through all three forms of a quadratic as well as how to find the line of symmetry, how to find the vertex, and then we'll do an example of finding the line of symmetry of each type of form. So we're going to start with factored form on the left. So our equation for factored form, or a formula, is y equals, I don't know why I said x, y equals a times x minus r times x minus s. And then the formula for the line of symmetry in factored form is x is equal to r plus s over 2. So that means that we would look in the formula at where r is, which is right here. We would take whatever number is there in our actual equation and put it here. We look to see where s is in the formula, take whatever number is there and put it here, add them together, and then divide by 2, and then that'll give us our line of symmetry. It's important to know that if you kind of mix up r and s, it's no big deal. Because these are factors, they can technically switch the order. So like if I wrote x minus s right here or something like that, it would still end up with the same outcome. So if you accidentally mix up r and s, it's okay. And then once you have your line of symmetry, you need that number to be able to find the vertex. So I'm going to move down to the next box right here. So once you have the line of symmetry, you substitute the x value from the line of symmetry into the equation, whatever equation you're given, and that'll give you the y value of the vertex. We're not going to practice that so much here. We have done it in the past, but we'll get to do that in future lessons as well. Okay, so for our example, we're going to find the line of symmetry of this equation, y equals 7 times x minus 4 times x plus 8. So I'm just going to write down the formula for the line of symmetry first. So I'm going to shorten it to LOS for line of symmetry. And then the formula itself is x is equal to r plus s over 2. So if I want to figure out what r is, I have to look in the formula where r is. It's in that first parentheses. So in my actual equation, I'm going to look in that first parentheses at what's being subtracted from the x. So in the spot of r, there's a 4. So r would be 4. And then to find s, I have to look and see where s is in the actual formula. It's in that second parentheses being subtracted from the x. So I look at what's there in that second parentheses, and there's an x plus 8. So it's kind of weird though, because in our formula there's an x minus. So we almost have to think of this as like there's an x minus here. And then if we think about what s value would turn that x minus into an x plus 8 would be negative 8. So instead of s just being 8, it would technically be negative 8. And it's just kind of one of those weird things where when there is a number in front, a negative in front of the variable that you're trying to find in your formula, it means it's kind of the opposite of what it looks like. So if we look back at, like for r, it was x minus r, and you had an x minus 4, and r is going to end up being positive 4. And then for s, it's x minus s. We had an x plus 8, and s is ending up being negative 8. So you kind of have to switch it anytime you see that there's a negative or a minus in front of the variable that you're looking for in your formula. Okay, so now that we know what r is, we can go ahead and put that in. So r is 4, so we'll put that in for r. And then s is negative 8, so we'll put that next. You can either write plus negative 8 or just a minus 8 is fine also. It means the same thing. And then over 2. And then we'll subtract 4 minus 8 is negative 4 over 2. And then negative 4 over 2 means we're dividing, so negative 4 divided by 2 is negative 2. And then we need to write our final answer for our line of symmetry with that x equals part in it. That part is important. So how the formula has x equals to start, so should ours. So it'll be x equals, and then it's the value that we got from our formula once it was simplified, which is -2. So x equals -2 is our line of symmetry. Okay, so just to kind of summarize for factored form, in order to find the line of symmetry, you have to figure out what number is in the spot of R, and then what number is in the spot of S, add those two together and divide them by 2. Okay, moving on to vertex form, the one kind of in the middle of our table. So vertex form is y equals a times x minus h squared plus k. The line of symmetry, its formula is x equals h. Sounds a little bit easier than when it's in factored form where we have the r plus s over 2. And then vertex form is, the vertex from vertex form is hk. It's kind of why it's called vertex form, because it's usually faster to find the vertex from that formula. So to find the vertex, if we wanted to find h, we would see, okay, what number is in the spot of h in the formula, and then what number is in the spot of k in the formula. We put h and k together as a point with h first and k second, and that'll give us the coordinates of our vertex. So now if we want to find the line of symmetry in this problem, it's y equals 6 times x plus 4 squared minus 2. The line of symmetry, again, I'm going to shorten to LOS. The formula for it is x equals h. So that means that I have to, and it's the same h as like this h in the formula and this h, that h in the vertex and that h in the formula. So then to figure out what my h is, I have to look in the formula, where is h positioned? It's inside of the parentheses. It's being subtracted from the x. So I look at what's there in my actual problem, and there's a 4 there, but there's a +4. So it's kind of like the last problem where we have to switch it. It's the opposite of what it looks like it should be. And h is going to end up being -4. And the reason is because this x minus is a part of the formula. So think x minus. And then the h that turns that x minus into an x plus 4 would be -4. So that means that h is actually -4. And then now to write my line of symmetry, I just have to take that h that I found and put it into x equals h where h is. So it'll be x equals, and then instead of h, I'm going to put in a -4 right there. So my line of symmetry is x equals -4. Okay, so moving over to the last form, which is standard form. So standard form is y equals ax squared plus bx plus c. And then I'm going to zoom out just so we can see the side on the left. So that second line is a line of symmetry. The formula for the line of symmetry is, in standard form, is x equals -b over 2a. So the b is referring to this b, which is the number in front of x, the coefficient of x. And then the 2, or the a in the 2a, is referring to this a. It's the lead coefficient, or the coefficient of x squared. So that formula is how we find the line of symmetry. So it's kind of similar to like the factored form when we had to do a little bit more work to get the line of symmetry. But finding the vertex is really similar between standard form and factored form. So once you find the line of symmetry, to find the vertex, you substitute the x value of the line of symmetry into the equation to find the y value. Okay, so for the example, we're going to find the line of symmetry for y equals 4x squared minus 3x plus 5. I'm going to go ahead and zoom back in. I don't really think we need the left side anymore. So our formula for the line of symmetry is x equals -b over 2a. And if we want to figure out what goes in for b, we have to look at the number in front of x. That's going to be b. And then if we want to look and see what's going to be in front of, or what's going to go in for a, we have to look at the coefficient of x squared. That's going to be our a. And then just for review, we don't technically need like c here, but this would be c right here. So standard form is like kind of in alphabetical order. A is first, it's the coefficient of x squared. B is second, it's the coefficient of just x, and then C is third, it's called the constant. It's the number that doesn't have a variable attached to it. So A is going to be 4, B is going to be -3 since it's a minus 3x. So we'll go ahead and put those both in. So notice that the formula has a negative in it. So there's a negative out in front, and then B itself is negative also. So you're going to have a double negative, one from the formula and one from B. And then over 2 times A, so A was 4, so 2 times 4. So when you have a double negative, that turns into a positive, so -3 turns into +3. And then over 2 times 4, so over 8. So we used our formula, I erased too much. We used our formula and it simplified down to 3/8. So we just need to finish writing our line of symmetry with the x equals out in front. So x equals 3/8 is our line of symmetry. Okay, so I would highly recommend like keeping this somewhere safe so you can find it and refer back to it. Even if you wanted to like take a picture or take a screenshot if like your work happens to be a little bit messy, so you can kind of go back and see this example. Okay, so moving on to 26.2, it's finding the zeros and plotting points. So we're going to do these examples 2 different ways. Example 1 is going to be by finding the vertex and the zeros, and we'll talk about what that means in a second. And then example 2 is going to be to graph with a table. Okay, so example 1, graph by finding the vertex and zeros. The actual equation is y equals 5 times x minus 3 squared plus 6. I just kind of put the formula up above it, kind of grayed out so we can refer back to it. So when you're using vertex form, which this is vertex form, the vertex itself, I'm going to shorten to just a v, is the point HK. So that has to be our number 1 priority to find that point. So if I want to find h, I look at where h is in the formula. It's in the parentheses being subtracted from the x. If I look at my actual equation, what number is there? It's a 3. And remember, like, this minus is already a part of the formula, so h is just going to be +3. And then for k, I need to look at what is in the spot of k in the formula. The k is added at the end, and there's a -6 at the end. So k would be -6. So we put that together in the vertex. We put 3 in for h, and then we put -6 in for k, and that's going to give us our vertex. So 3, -6. And then now that we found that, I'm just going to go ahead and graph that right away. So the first one is the x-coordinate. That's how far you go left or right. So we would go right 3 to right here. And then the second one is the y-coordinate. That's how far you go up or down. So I would go down 6 right here. So 3, -6 means we go right 3, down 6, and we put that point there. Okay, and then if we kind of read through like the directions for the example one more time, it says graph by finding the vertex. Like, okay, we just did that. But then it says, and the zeros. So the zeros, that's a vocab term we've talked about before, but sometimes it's easy to forget because it seems kind of like a funky word. So zeros mean the value that makes the equation or the function equal to 0. So the way that we do that is we put 0 in for y. So I'm going to put a 0 right there, and it's going to replace y in the equation. So instead of y equals, it'll be 0 equals, and then the rest of the equation will stay the same. So 5 times x minus 3 squared minus 6. And then now I need to solve this equation for x. So this is kind of like a solving by square root situation where we would want to get the part that's being squared isolated. So there's 2 things being done to what's like being squared. So the x minus 3 is being squared, the 6 is being subtracted from it, and the 5 is being multiplied by it. So first I'm going to cancel out that 6 that's being subtracted by adding 6 to both sides. So then 0 plus 6 is 6, and that's equal to 5 times x minus 3 squared. And then the goal is to still get the portion that's being squared by itself. So now I have that 5 that's being multiplied by it. So to cancel it out, I would divide both sides by 5, since division cancels out multiplication. And then over here on the left, I have 6/5. I'm just going to leave that as a fraction. It's okay. And then that's equal to 5 divided by 5 cancels out. And then x minus 3 squared. So now the portion that's being squared is isolated. So now I want to get rid of the exponent. That's like kind of one of the last few things I can cancel out. So if I want to cancel out the exponent, I have to square root or both sides. I create that radical. So that radical or the square root cancels out the exponent. But if I do that to the right side of the equation, I also have to do it to the left side of the equation. So I have to do it to the 6/5 as well. So when we take the square root of anything, we have to include the positive or negative outcome of it. And then 6/5, I'm just going to leave that alone in the radical for right now. And then that's equal to on the right side of the equal sign, the exponent cancels out, so I'm left with just x minus 3. Okay, so I wanted to get the calculator popped up just so we can go through this next part together. This is just the Google calculator, so if you just Google calculator, it'll pop up. But I need to take the square root of 6/5. So if I want to take the square root of 6/5, I would click on the radical on the calculator, and that's the kind of looks like the 4th row and the 3rd button over. And then to type in 6/5, I would do 6 and then divided by 5. Because fractions are just like dividing, so 6 divided by 5 is the same thing as 6 over 5. And then I would click equals, and that's about we'll say 1.1. So 1.1, and then this is going to be a positive or a negative 1.1, and then that's equal to x minus 3. And then we don't really need this anymore, so I'm going to try to get rid of it. I'm not very good at this though. Oh, it kind of worked. Okay, so the square root of 6/5 is about positive or negative 1.1. And then now, because I have kind of a positive or a negative version, this is where I need to separate it into two equations. One that has a positive 1.1. So we do positive 1.1 is equal to x minus 3. And then one that has a negative 1.1. That's equal to x minus 3 as well. Notice I didn't change the x minus 3 part. I just changed the 1.1 into like 1 being positive and 1 being negative. And then now we solve each equation separately for x. So if I want to cancel out the 3 that's being subtracted, I would add 3 to both sides. So then 1.1 plus 3 would be 4.1 is equal to x, and then I would add 3 to both sides over here also. And then negative 1.1 plus 3 should be 1.9 is equal to x. So what we just did, we put 0 in for y at the very beginning up here, and then we solved the equation, and we got x equals 4.1 and x equals 1.9. So those are our zeros. So zeros are where the graph crosses the x-axis, so they're x-intercepts. So those are going to be our next set of points. So whatever numbers we get, and I'm sorry they're decimals, try to keep the same example that was in your workbook, we're going to put points there on the x-axis. So remember, the x-axis is the one that goes side to side. This is the x, and this is the y. So for the first one, for 4.1, I would put a point, and see how close I can get. I would put a point like just slightly after 4, like maybe right here. It's really hard to make it accurate, so just do your best. And I would put a point for 1.9. It's like a little bit less than 2, so I'd put a point like a little bit under 2. And then now I can connect my points because I know this is a quadratic. I know it should be shaped like a parabola, so I go like this and like this. And that's my graph. I created a parabola. Okay, so for example 2, graphing with a table. So this kind of problem comes in handy like if you have a parabola that maybe won't have zeros. So I'll show you kind of how we can determine that in a second. But when we graph with a table, the middle of your table, if you have 3 points, the middle should always be the vertex. So we want to find the vertex from our problem. So same thing here. Remember, the vertex is the point HK. So for H, we look to see, okay, what is in the spot of H? There's an x plus 4 there, though. Remember, H is kind of like the opposite of what it looks like it should be. So H would be -4. So for our vertex, we would have a -4 first. And then for K, K is added after, and there's a +1 there. So K would be 1. So we put a 1 in second for K. So our vertex is -4, 1. I'm going to put that in the middle of my table. And then I'm going to also put that on my graph right away. So -4, 1 means I go left 4. And then I go down 1. So I'd put a point right here. So -4, oh wait, nope, why did I say it? Oh, maybe you guys noticed my mistake and we're like, what? Okay, sorry. Anyways, -4, 1, I would go left 4 and then up 1 because it's a positive 1. Hopefully you guys caught me and we're just thinking I was kind of dumb. Okay, so -4, 1, let's see, I go left 4 and then up 1. Okay, so now think about like this parabola. If we look at the A value tells us if the graph opens up or opens down. So we have a positive A value, which means this is not going to be the actual graph, just a sketch, but it means the graph would be going up. So it would mean there would be no x-intercepts, which means there would be no zeros. So we couldn't use the same strategy for this problem to get points. So that's why we'll use a table. So when you use a table, I just want you to go like up 1 value from the vertex and down 1 value as well. That's why we put the vertex in the middle. So like if I go down 1 from -4 would be -5, and then up 1 would be -3. So then now just pick one of those numbers to put into the equation. So let's see, I'm gonna do -3. So I'm gonna rewrite my equation right here and then put in -3 for x. So it'll be y equals 2. The equation itself is x, and then plus 4 squared plus 1. I'm going to put a -2 in for x, and then simplify. So y equals 2, and then times -3 plus 4 squared plus 1. And then I need to follow order of operations, so I would simplify the inside of the parentheses first. So it'd be y equals 2 times -3 plus 4 is 1. And then squared plus 1, and then I would simplify exponents next. So y is equal to 2, and then 1 squared is 1 plus 1, and then I would multiply next. So y equals 2 times 1 is 2 plus 1, and then finally I can add these two together. So it'd be y equals 2 plus 1, which is 3. So that means that I put in this like 3 for where x was, and then I put in -3 for where x was, and I got out a +3, so I would put a 3 over here on the table, and then I'm going to put that point on my graph as well. So I go left 3 and then up 3, so it'd be right here, left 3, up 3. And then you could repeat that same step with this other number from the table, but you don't necessarily have to, because we know that every parabola has a line of symmetry, which is a vertical line that goes through the vertex, which this point was our vertex. That was the first one we put on there. And all of the points can be reflected over the line of symmetry. So that means that I can take this point and reflect it over the line of symmetry. So it goes from like 1 to the right to 1 to the left over here. And I can put a third point right there. And then now I can just connect my points in that U shape and have my parabola. And if you don't really feel comfortable with that, or like it doesn't really quite click, you can use the same strategy on the table and you would get the same outcome as we did for -3. So I'm going to go ahead and put a 3 right there, because both of those points will end up having a y coordinate of 3. Like this is -5, 3, and then this is -3, 3. Okay, so just kind of like a shortcut you could take if you don't feel like putting that x value into the whole equation and kind of simplifying it. Okay, so moving down to 26.3, writing the vertex form from a graph. So vertex form, again, it's the same formula. It's y equals a times x minus h squared plus k, and the vertex is hk. So example 1, we're going to write vertex form from the vertex and zeros, or really just 1, 0. So the first thing that we need to do is we need to look at the graph and we need to find the vertex. It's the point where it changes direction. Then we need to find that actual point. So this is at 4, 8. So the vertex is 4, 8. And then I know the formula for, not formula, but the kind of like structure of the vertex is hk. So the vertex is hk, and our actual vertex was 4, 8. So that means that h is 4 and k is 8. So when we're trying to write the equation, those are the first two things I'm going to put in. I'm going to put 4 in for h and k, or 8 in for k. So that'll be my first step. So y equals a times x minus h was 4 from the x coordinate of the vertex, and then squared, and then plus k was 8, and that was from the y coordinate of the vertex. So find the vertex first, and then use that to figure out what h and k are before putting them into the formula. And then from there, we still have to figure out what a is. So to figure out what a is, we have to pick another point that's on the graph and put them in for x and y. So it can be any other point that you know, but usually it's easiest if you can find like an x-intercept or a 0. So we can use either 6, 0, that's that point, or 2, 0, that's the other x-intercept. I'm going to use the 6, 0. So 6, 0 is going to be my extra point, or like my 0. I'll write it down here, 6, 0, and I'm going to put those in for the x and the y in the equation. So we'll put 6 will go in for x, and then 0 will go in for y, because that's how points are ordered, as x, y. It's just the vertex that we refer to as h and k. So 6 will go in for x, and then 0 will go in for y. So it would become 0 is equal to a, that's what we're trying to find, times x is going to be 6 minus 4 squared plus 8. And then now we simplify to solve for a. So I would subtract inside the parentheses first. So 0 is equal to a, and then 6 minus 4 is 2 squared plus 8. And then next I would simplify the exponent, so I would square the 2. So it'd be 0 is equal to a times 4 plus 8. And then our goal here is to get the a by itself. I need to start to isolate it. So first I would undo the 8 that's being added to the a. So I would subtract 8 from both sides. So this would be negative 8 is equal to a times 4. If you want, you can write it as 4a, like switch the order like we typically see it. And then we want to get a completely by itself, so we'd have to cancel out the 4 that's being multiplied by a. So you divide both sides by 4. 4 divided by 4 would cancel out. And then I have negative 8 divided by 4, which is negative 2. And that's equal to a. So then now we take that negative 2 that we got for a, and we put it back into this equation that had the x and the y still there, but did have h and k put in. So we have y is equal to negative 2 goes in the spot for a, and then times x minus 4. That was h for 4. And then plus k at the end. K was 8, so plus 8. So y is equal to negative 2 times x minus 4 squared plus 8. So this last example, it can technically be an extra example if you felt very comfortable with example 1. The only thing that's different about this example is that we're not given an x-intercept. So when we go to solve it, we'll still kind of follow the same steps. We just won't have a point like 6, 0 to put into the equation. We'll have to use a different point. Okay, so example 2, using the vertex and an extra point, write the equation of this graph in vertex form. So the same first step, we need to find the vertex from the graph, which on this graph, it's -2, 1. So the vertex kind of like structure is HK, and we got that our vertex was -2, 1. So h is going to be -2 and k is going to be 1. So we'll take those and put them both into the equation first. We'll put -2 in for h, and then we'll put 1 in for k. So it'll be y is equal to a times x minus, and then h goes here, and h is -2, so it'll be x minus -2 squared, and then plus k goes right here, so plus 1. We didn't have to do this in the last step, or the last problem, because h was positive, but here we really need to go ahead and simplify this double negative into a plus. So y equals a times x minus -2 is going to simplify to x plus 2 squared plus 1. And then now we need to pick another point to help us find x and y that's going to let us solve for that unknown a value. So it can be any point that you know on the graph. So we have this point right here, this point right here. I'm going to go ahead and use this one. So, JK, I changed my mind. Okay, you can use either point, but I don't know why I like second guessed it, but either one will get you the same answer. Okay, so that point is -1, 4, because I go left 1, up 4 to get to that point. So the extra point is -1, 4, and then that's going to go in for x, the -1, and then the 4 is going to go in for y. So I'll put -1 right here, and then I'll put a 4 right here, and then that'll allow me to solve for a. So it'll be 4 is equal to a, we still don't know that, and then parentheses, -1 is going in for x plus 2 squared plus 1. So 4 went in for y, -1 went in for x, and then now we can simplify to solve for a. So if I want to simplify, I'm going to move this maybe. See if I can move it. Moved it way too far. Okay, anyways, it was just kind of in the way. Okay, so same order for simplifying. We simplify the inside of the parentheses first. So 4 is equal to a times -1 plus 2 is 1 squared, and then plus 1. And then we will square next. So 1 squared is going to be 1. So 4 is equal to a times 1 squared is 1, and plus 1 right here. So a times 1 is just 1. I don't really need to like write that. So I can, or sorry, a times 1 is just a. So I don't need to write a times 1. I can just like write a, because they're the same thing, and that would definitely make the equation a little bit more simple. So I'm going to go ahead and just change it to 4 is equal to a plus 1, and then my goal here is to get a by itself, so I have to cancel out that 1 that's being added to it. So then I would just subtract over the 1 to cancel out the 1 that's being added. So 4 minus 1 is 3, and that's equal to a, and that a is going to go into the equation up here, the one that had the x and the y still in it. So it'll be y is equal to a, which is 3, and then times x minus h, but h was -2, so that turned it into a plus 2 squared, and then plus k at the end, so it'll be a plus 1 at the end. So altogether, y equals 3 times x plus 2 squared plus 1.